So, no more slides for the rest of the day.
Hey, no slides!
We have a whiteboard and the strength of our personalities. So, actually, we're done with product stuff for the rest of the day for the most part. It's really, we want to dig into a couple of topics and really get a little more dialogue and conversation, because we certainly have our perspective how we think the market is evolving. We'd love to, just engage in some conversation about your perspective on that. We're talk about, Jan's going to talk about hybrid switching. As I said earlier, he led the work group in ONS on the topic, so he's done a lot of thinking about it. So he's going to share some of the things they came up with in terms of things you should be cognizant of. And I think as customers actually try and move from the unicorn version of SDN to the plow horse version of SDN, there's a lot of, okay, how do we get there? What are the practical issues to think about? So I think it should be a good conversation. After that, we're going to wing it a little bit. So Prashant Gandhi, who leads the O&E effort from the engineering perspective, from a product management perspective, is going to be on. So there are a couple of things we can talk about to wrap up the day. We thought one of the products that he's responsible for is the Nexus 1000V Intercloud, which is our hybrid cloud solution. So we can talk about that. We could talk about service chaining, which is something we always get a lot of questions about, our VPath technology. So we'll just kind of be agile and figure things out. But before we kick off, a small piece of business. So I like to be, I'm kind of a big fan of closing loops in the whole circle of life kind of thing. So 19 years ago, and this kind of hurts to say, I met Terry. I actually sat in one of his classes on my way to getting my CCIE. So back then, I still did subnet, I still needed pencil and paper to do subnet masks and those kinds of things. So since you were here, and it was an honor to be able to host you and be able to close that circle, I want to honor you as the first CCIE with a heartbeat.
We should have saved that other guy.
So the first CCIE number is actually the lab. So Terry was the first one to get a CCIE number that that breathes.
I was the first one that actually took the test.
Yes. So, thank you.
Thank you.
Well done.
Those were the good old days. They actually gave you medal when you got your CCIE back then.
It's a piece of the lab.
It is a piece of the lab.
I gave it to him.
It's a 2500.
It looks like it's clothing. Cool.
Wow,
All right.
fantastic.
Excellent.
That's actually a nice jacket.
Yeah.
Yes, it is. This is excellent.
And it's not from the outlet.
Thank you, sir.
Okay, and with that, I will hand you over to.
Okay. So maybe I'll start with a question. What would you like to know about hybrid switching, or what do people think about hybrid switching?
Let's go back to
what
the first
hybrid
question.
switching is?
Yes.
Okay.
Define hybrid switching.
Yeah, define what we're going to talk about from your perspective so that we know how to frame our
I've not
response.
heard the term before.
Well, it can mean, as you pointed out, it can mean multiple things to multiple people. So maybe what we try to do is first try to frame it within the ONF framework, which is hybrid switching in context of OpenFlow. Just to give you a little bit of background, I was one of the co-chairs of the hybrid switching working group in ONF. The group has concluded its work a few months ago. The ONF board felt that the group has done whatever it needed to do, and it doesn't need to be doing any work anymore. And ONF wanted to pursue more kind of pure OpenFlow switches and hybrid network environments. What the group was doing was looking actually both at hybrid networks and hybrid switch devices. It's like two different things, and we can talk about it in much more greater detail as we go forward. But the ONF board's position was, well, we really want to look at pure OpenFlow switches. We're about pursuing, yes?
So when you say hybrid, you mean combination of doing doing OpenFlow and doing regular switching, running spanning tree, stuff like that in one box or within one network when you say hybrid?
Correct. That was
Okay.
well, we actually never quite got to a definition of a hybrid network. Okay.
After how many years, you mean?
The group was in existence for about 9 months, and we always struggled with the concept of a hybrid network. What is a hybrid network? According to Nick McKeon, a hybrid network is any network which contains OpenFlow switches. It has OpenFlow and it has legacy quote-unquote control plane, so it's a hybrid network. But, you know, when you actually start thinking about it, is it really a hybrid network or is it not? I mean, would hybrid network, because if that's a hybrid network, then we've been having hybrid networks for 50 years now, right? I mean, we've got different devices and different types of devices with, you know, different capabilities in a network. Now, when you look at it, what would really a hybrid network be if we took the definition of the hybrid switch, which we came up with, and that was within the context of OpenFlow, it was fairly simple. It has the OpenFlow control plane, which means a connection to an OpenFlow controller, plus a legacy control plane, and operating on a common data plane, on a common forwarding pipeline. That was roughly the definition of a hybrid switch, and that was relatively easy to arrive at, and we got pretty good consensus on that. If you try to apply the same concept or the same principle to a hybrid network, you would have to have 2 control planes in a network. But any kind of a network that is actually in existence has only 1 control plane, which is pretty much IP. Even the Google network, you know, which they build out of the OpenFlow switches, it has an OpenFlow controller, but you know what drives the network on top of that is BGP. It's Quagga and IGP and BGP. It's basically an IP routing stack, right? So, you know, would a hybrid network be something that has 2 control planes? If it's 2 control planes, how would that work? You know, what would the other control plane other than IP be? These are all questions, you know, that actually just start going down the rabbit hole rather than coming up with a solution. So I think the simplest way that the board wanted to have the question answered is, well, a hybrid network is anything that has an OpenFlow switch in the network. And in the end, I guess that's what we agreed on. So what is happening now is the ONF is trying to put together, as you probably all know, I mean, if you're receiving the ONF reports from Dan, we're trying to put together a working group which would be focused on hybrid networks, which would be driven by operators. By interesting choice, you know, in the hybrid working group, in the first incarnation of the hybrid working group in ONF, most of the people who did work in the working group were representative of hardware vendors. So we got guys from Juniper, we got guys from Marvell, from Broadcom, doing really good work. A couple guys from Cisco, you know, guys from BSN. So vendors, not operators. We did not have a single operator in the group. Kind of, you know, somebody with an experience how to run an OpenFlow network or a hybrid network. Yes.
So, when you say being built of operators, I assume we're talking about operators that paid the $30,000 to be part of the ONF?
No, operators that will actually deploy OpenFlow in their networks.
So you're saying they're looking outside of the ONF to bring people in to help define this?
There is a subset of those who pay the $30,000 and who are running OpenFlow in a network. Google being one of them, right? I mean, they've got this G-scale network, which is OpenFlow driven, right? It's probably the biggest OpenFlow network in the world. Then you've got some guys like NTT who went public with having OpenFlow in a network and pursuing. So I personally am not aware of anybody else who would actually have anything. But you know, there are operators who are playing with OpenFlow and trying to deploy OpenFlow in the networks. And ONF is trying to get this working group, which would be consisting primarily out of operators, up and running, and people should be exchanging experience or, you know, coming up with how a network should be designed, an OpenFlow network should be designed, and how a legacy quote-unquote network should be migrated onto an OpenFlow network.
Well, so and that's what I'm getting at. So that group of operators is coming out of the mining companies.
That would be it. But as as I said, I haven't seen this group. I mean,
Sure.
there is an interesting thing going on, and from what I know, they're still trying to define the charter for the group.
Yeah. So is any of the work that you did with the hybrid working group, is any of that getting published, or is that all gone?
That's a really good question. The board decided not to publish any of that.
So I'm kind of curious when we talk about a hybrid. So I
So
think some of us can
To
help.
qualify the discussion, you work at an operator.
Right, but yeah, I mean.
So
but
the
I mean,
hybrid group that I led on,
entry
we
fee.
created like 4 documents. Terminology, we created a kind of an use cases, architecture for a hybrid switch we actually described architectures for hybrid switches. So, guys from Broadcom and from HP gave us the blueprints, and we gave examples of how a hybrid switch can be built. Those 4 documents have been delivered to the board, and from what I know up till now, they haven't been published.
So, I mean, when we're talking about a hybrid, I mean, I think some of us in the room could pretty easily define that. There's 2 pipelines. We can have some interaction between those pipelines, right? Something as simple as OFP
A
normal.
hybrid was kind of a single pipeline, and how do you have 2 control planes working on a single pipeline? And how do you logically divide that pipeline between the 2 control planes?
So, but I mean, so if I have 2 VLANs ships in the night on one switch?
Yeah, the ships in the night was one of the models that we pursued.
Right.
So basically, you could have either a port-based separation or you could have VLAN-based separation, right? So ships in the night, kind of the easiest model, the easiest to wrap your mind around, and that we proposed that was the least controversial thing. And that kind of enables virtual slicing, it enables to create for researchers or for people who want to experiment with OpenFlow a separate data and control forwarding plane. Here is your network, do with it whatever you want. But still, this did not assume or presume that the underlying pipelines are actually 2. But there was a set of resources that OpenFlow could see. And so basically, with the ships in a night, you've got a virtual OpenFlow switch inside of a physical switch that controls a subset of resources of that physical switch. Now, and we had all those discussions whether when a packet comes, whether it first comes into the regular control plane or whether it first comes into OpenFlow, then what does normal mean, what does regular mean, all that stuff. And we came up with definitions of that, and it's all captured in those documents that haven't been published. Okay, so but one part of the resources on the switch have been kind of allocated to OpenFlow, and OpenFlow could completely control that, and the other part was for the legacy control plane, legacy in terms of And we actually thought a little bit more, not just layer 2. I mean, for layer 2, it would be a layer 2 forwarding switch with spanning tree and what have you. For layer 3, it would be a routing control plane. So because you could have, and there are implementations out there of kind of hybrid devices where you can have, for example, OpenFlow built in a router. On top of VPLS or a bridge instance, right? And you can kind of OpenFlow enable that. And then when you do forwarding from that bridge instance through logical ports inside of the router, I mean, the layer 3 control plane takes over and forwarding plane takes over, and then packets are then being delivered over layer 3 wherever they go.
Well, it's solving the edge, right? So we're always
Yes,
gonna have this
that's
native
solving
core,
the edge.
And that's where the problem is classification on ingress.
Exactly.
So, I mean, with what we have today, even with that group not doing anything or not publishing anything, we can do that today, right? So.
Oh, we can do that
I can
today,
take
yes. There's
ingress
implementations
packets.
that do that,
Right,
yes.
so I can peel whatever I have for the initial application, drain everything into
Yeah.
normal. So,
And-
but we need vendors to support that, right?
Yeah.
And it's vice versa on pipeline.
And at the end of the day, that's where it comes from, right? I mean, we touched on this morning. Our belief is a cool use of functionality, and ultimately we see programmability behind this horizontal function across the network. We also see the practical adoption model be incremental. So outside of what ONS does or does not do with the work that was already done, this is near and dear to our heart because there's a lot of our customers that are looking to get from here to there and looking for those hybrid adoption models. Say, okay, I don't want to break what I've got that's working, but there's cool new stuff, and I want to be able to roll it out not in a duct tape model, but actually kind of have something that looks reasonably well engineered.
And without
To be able to play.
ripping out all of our gear
Yeah.
in order to start testing this, so that
Yeah, and
requires.
that takes me
Absolutely.
back to the argument I've been having with you, is that our gear's too expensive, right? So one of the reasons that we don't want to rip out our gear is because the networking equipment that we buy today is costly. Everything that I buy in a network is on a 5 or a 7-year ROI cycle. So I can't take anything out of my network to do new stuff because just
Exactly.
costs
That's the approach that we took, for example, with the 9K or the implementation in Cisco. It's really take a virtual instance of virtual switching instance inside of a router
yeah.
and OpenFlow enable it. And you can have it either ships in a night. Well, this is basically ships in a night implementation.
What you can do is say this port belongs to OpenFlow and that's it. And at a
Yeah.
port level,
Yeah.
this one goes into it
right.
acts like a normal rooted bridge.
And we actually use this in other applications. We use OpenFlow as an API to drive ACL programming to do exactly what you mentioned, which is peel a part of the traffic in a certain way, and then the rest is forwarded in a default manner, which is one of the biggest advantages of a hybrid device. So you don't want to completely move onto OpenFlow, which is kind of a unproven technology. It's a completely different paradigm from networking today. Networking is distributed by definition, distributed control plane. We worked on it for 50, 60 years. It's a reason why it's distributed. I mean, it's been for resiliency and availability. It's been designed, the first internet has been designed to survive nuclear attacks, right? So, there's no single point of failure, the network is self-healing, self-adapting. And that's principles, that we worked on for 60 years now. And you replace that with a centralized control plane where all the intelligence is, in one place. And it may be logically distributed, but it's still in one place. It's an unproven model, put it this
Our
way.
administrative domains, I don't need nuclear war fallout survivability, right? I need business logic integrated into the network.
Yeah.
So
I need to be able to peel a flow off and munge it.
Yes, absolutely.
Independently. I
So,
need to be able to say,
that's
this group of ports are treated differently from the rest of it.
Right.
And I understand what you're saying. Internally, inside, if you've got a TCAM, who's feeding entries into the TCAM, and what happens if the TCAM entries overlap, right? So if you punch an OpenFlow entry in and it overrides a span entry in the TCAM,
Absolutely.
how do you arbitrate between
Absolutely.
competing? And that's the pipeline discussion, I believe, right?
So-
empty table should theoretically, that takes
Right.
away a lot of the race.
There is, I'm not arguing that centralized doesn't have a place in a network. But the kind of basic substrate, the layer 3 or the routing, when everything else fails or the centralized entity fails, I have to have something to fall back on, and I'd like to have the distributed layer underneath. I can have traffic engineering optimizers or demand admissions like path computation element or what have you, which has a better view of the network than what the individual routers have. If I want to do traffic steering or traffic engineering and do anything else than default routing, this other intelligence can do measurements in a network and can steer the traffic around hotspots and what have you, and kind of in real time optimize the network.
Why does a networking device need to do spanning tree and routing and MPLS and MPLS TE and a kitchen sink, a paintbrush and a pair of rubber gloves
Right.
and a little fluffy toy, right?
2,000 other RFCs.
Right.
I'm not 100% sure that OpenFlow, even in a hybrid network, I don't think there's that many campus networks even implementing MPLS, because MPLS is expensive to implement. To implement one MPLS feature, you require a larger TCAM, because every MPLS label needs to load a path into the TCAM that matches that table. So a
Right.
3750 would suddenly go from being 55, being 5,000, 700,000 unit cost to being 50,000 because the TCAM's now twice the size and
Right.
it will draw twice the power.
Exactly.
So in a campus network, we don't need any of this stuff that operators need. So what Verizon and Google are trying to put into their OpenFlow implementations are irrelevant for what campus
Mhm.
needs.
Which is what, where that translates is we see who's actually deploying this stuff in the actual use cases. It's all the operators. If you look at adoption on the operator side versus adoption in the enterprise, it's wildly different.
Yeah.
Because on the enterprise side, for the most part, they've invested in expensive infrastructure, they've invested in expensive, rich management systems. So they have a lot of that stuff. And I think Ivan made this analogy about taking the round wheels off a car and putting some,
Yeah.
new, slightly less round wheels on and being proud of that. And I think that's where a lot of the conversation is. I think we're getting to a pivot point where we're starting to be able to do stuff with programmability that we can't normally do with the current protocols and those kind of things. And I think that will start to get people's attention on the enterprise. And like some custom routing, some of the stuff we talked about this morning in the 1TK discussion, where, hey, here's stuff that we can do in a much more cost-effective and a much more feasible perspective with controllers, with protocol, with programmatic controls that we can't necessarily do with MPLS or whatever, or not have it look like it's all, duct tape and baling wire.
Well, I think the flip side here is what we're seeing in terms of Open vSwitch and the level of innovation that's occurring there. And we're now seeing, different forks of Open vSwitch. Some people are taking it off to do BGP and attaching an XMPP interface on the BGP to be able to program the edge.
Mhm.
Other people are adding extensions to OVS to do rewrite functions that emulate routing functionality, and then hitting the flow into a tunnel,
Mhm.
right? I think as Open vSwitch gets more penetration, largely due to OpenStack, right, people are going to start challenging whether a router is actually a network device anymore. What we actually want is a packet processor. I don't want a router. I don't think within 5 years we'll be talking about routers or switches. I think we'll be talking about boxes that do packet processing.
Well, we've
And
had
there will be
routes.
software versions of that, which is a software vSwitch, like a la Nicira, a la Open vSwitch, a la what Microsoft's doing with their NVGRE hypervisor. And there'll be physical packet processors, and they just move flows according to some arbitrary rule set. I don't think routers will survive. They won't be the only network processing device in the future.
Okay, the second piece I'll agree with. I mean, we've had Route D for forever, so it's not like routers are really the only things that have ever done, network policy enforcement. I think it comes down to where do I invest my time? And if I have a bunch of stuff that works already, what's going to get me to the next piece, and how do I get there in a way that's cost effective? And I think this is where the hybrid piece becomes the important conversation. Is okay, there's cool new stuff I want to get. And when you have this with anything, it's a new line card, it's a new whatever. How do I get there, and how do I still preserve what I just bought and I'm still paying off, and not mess with the 80, 90, 97% of stuff that's running? I don't want to mess with it again and reinvent the wheel. In an enterprise, in the service provider environment, you have one or two types of jobs that you do a million times. In the enterprise, it's the other way around. You have like a million different types of environments
Well, you also
that run 1% of the time.
Well, the enterprise too, you also know your system.
Yeah.
So in an enterprise, one person usually, not always, but conceptually, knows the whole thing. They can actually see down through the backbone to the WAN edge, to the LAN edge, to the access layer, and they also get visibility into the data center. There's one small team who sees the entire stack. Whereas in a service provider, operationally, there's probably nobody who actually understands the entire stack. Because, they might have a 3G and a 4G, and in a 3G network you need to understand GGSNs and SGSNs and termination of 3G PGP protocols in various points in the network, but in 4G you're running into a completely different network architecture which runs into an MPLS backbone which is using DWDM. It's not possible to be across all those domains and to be coherent in the architecture. And I think OpenFlow says we can bring all of that stuff down to a simple primitive, and attaching too much importance to the legacy is probably going to hold you back.
Well, we innovate with protocols and RFCs, and then there's this domino effect. Every other RFC you're already supporting, right? I mean, we've got to get to the point where you can actually deliver. I mean, NFV is no different, right? They want to deliver applications in much shorter times than what they have. I mean, in enterprise security, look at BYOD. We've been talking about horrible BYOD strategies for years. not Cisco, I mean, just in general, right? And it's just classification as you come in on the edge. But every single one of those are not portable to any other network, any other device. I mean, it's just, we need fundamental instruction sets to kind of start abstracting, get somewhere.
Yeah, I've been in ONF multiple working groups trying to even define like a kind of common data set for the forwarding device.
Yeah.
And even that is proving to be something very, very difficult.
Yeah.
I actually think, this may be an abstraction, actually the wrong abstraction level, too low. Because if we define maybe at a higher level a set of operations like these forwarding operations, that kind of are more at a policy level rather than individual flow level, that in the end may be a better approach. Because you've got all the forwarding pipelines. The individual vendors want to, hardware vendors want to innovate, right? I mean, Cisco wants to differentiate themselves from Juniper. Marvell wants to differentiate themselves from Broadcom. So how do we come to a common set of features or operations that should be defined for forwarding packets?
Yeah.
You need a paradigm for understanding it. I totally agree with the packet processing, but it's just this mush of stuff that can happen. It's maybe hard to wrap your fit your brain around. Whereas if you think of it as I'm doing a layer 2 rewrite or a layer 3 write or a server load balancer rewrite, you do get into the question of sequence of operations perhaps, which gets a little sticky. But maybe by partitioning it like that, it becomes easier for, maybe it's just us versus newbies to the field.
Right. The other thing that was kind of interesting, and it's actually interesting on all the interops, is even if everybody defines the same operation set, the performance points are extremely different. Because some of these operations in some implementations have to be defined in software or don't go in the ideal data path. So theoretically everybody supports everything, but you try to put it in a network and some devices have good performance, some don't for a particular set of applications.
Yeah.
So
I figure we'll have like flashcards, you'll have a class 1, a class 2, a class 3.
yes.
And and a class 1 will be a 50 flow per second switch, and then a class 2 will
right.
be a
But
300 flow per second.
we've got to get to that unification. But until then, we just move the work from so I've got this kind of common substrate, and I got away with all that vendor's complicated control plane, and I replaced it with my open source. But who's going to integrate this? Who's going to test this? Who's going to make sure that it all works? That in itself is an entirely new set of problems. And so we're in agreement that things are changing and will change. But and I was not saying that OpenFlow is good or bad or stuff like that. It's just an entirely different set of problems that need to be solved, and we don't have experience with it. Whereas we have experience with the other type of networking. So doing the approach that was suggested, where you peel off maybe a certain percentage of the traffic, get experience with that without affecting the rest of the traffic, and that's like the sensible approach, because we're going to figure out what the scaling is. We're going to figure out what the failure scenarios are going to be. The different paradigm of centralized versus distributed control plane, right? I mean, things will go wrong in very different ways, right? It's an interesting new world.
Yeah, well, I mean, but that's so part of what you're basically, that one little application, we're talking about an industry that hasn't necessarily evolved outside of silicon in 15 years. So
yes.
That one little piece is, that's going to be a ripple effect, and that's going to be some domino. Oh, I can just forward this, and now I'm tapping, and now I'm taking something that used to cost me $500,000 to do it 10, 40, 100 gig. Now I'm doing it $5,000.
Right.
All the more reason we need hybrid architectures, right?
Oh yeah, definitely. And I would actually think, that we need maybe APIs at a higher level, where these systems are not really done, not just kind of couple inches about the hardware, but have some software intelligence, and you kind of program it at the policy level. Maybe you program it at the rig level rather than having to deal with forwarding pipelines. For power users, you absolutely need to talk forwarding pipeline, but it's extremely difficult to unify that kind of an API.
Can someone just define for me what you mean by pipelining? Because you're talking about two separate pipelines, right? One for the normal forwarding. When you say that, would it?
A forwarding pipeline is something, when a packet comes in on an interface, then you have to strip the header off, you have to do a lookup, then you have to
You're just talking about the path that a packet takes through a device. Okay.
through the router or switch. And you've got different types of pipelines. You've got a layer 2 pipeline for switches, and you've got layer 3 pipeline typically for routers, right? And they are different. And some of them are very simple. Some of them are complex, because if you need QoS, if you need, like as you mentioned, like MPLS forwarding, IPv6, this and that, I mean, it just gets very complicated very fast.
What actually happens inside the chip?
Order of
So a
operations.
packet comes in on the chip interface.
Yep.
So normally it'll pass through a layer 2 engine, processing engine on a Mac, get the Ethernet header will be stripped and then pop into the system on a chip. So if you think on a 6500 blade or a 7000 blade, behind that is a replication engine which decides if it's a broadcast or a multicast. If it's a multicast, then it breaks the stream into two pieces and then it passes it into a forwarding chip. Well, what does that forwarding chip do? It looks up an address table to see where's the next hop. If it needs a rewrite, it gets passed into a rewrite function on the silicon to rewrite the TCP header and calculate the CRC check and inject an MPLS tag and rewrite. All these things are all done in a data pipeline through the chipset in the silicon. We don't normally think about these things in day-to-day because they're invisible to us. When it was switching or routing, it was actually very simple. A packet comes in, it doesn't really matter where it came from, it only matters where it's going to, because we only care about the destination MAC or the destination IP. Now in the OpenFlow world, we care about your source MAC, your source IP, your destination MAC, your destination IP, your source port, destination port. And then we're going to carve out a flow from that. So
And
how do you run that through the processing engine?
See, this was what I was alluding to before. Most of the pipelines are kind of optimized for the existing forwarding. Like, didn't matter where the packet comes from, just where the packet is going to. So, for certain types of OpenFlow lookups, when you only match on destination MAC addresses, or only match on certain set of fields that the hardware is good for, it can go through a hardware pipeline. As soon as you have to match, you kind of out of the realm of what the current hardware can do, you've got to punt that packet typically to a processor, process in the software, and inject it back. And it's a few orders of magnitude slower performance.
Right.
Now, there is hardware coming on the market, that can do a couple 100,000 of flows with, full match capability at full performance. But everything has its cost, So if you want this flexibility, I mean, then you've got to put in more hardware, and it's more cost. So, are the OpenFlow switches necessarily going to be cheaper than really the cheapest commodity hardware? That's yet another question.
But isn't that a good story for the vendor, though? Because I firmly believe that the hardware is going to stay the same. The consumer is going to get more capability out of it. And that's going to stay fairly fixed unless you're hyperscale.
Or should we all just move to the x86 forwarding pipelines?
Right.
I don't know. I mean,
So
that's
hyperscale,
the power is
definitely.
getting there, for certain set of applications, certain set of speeds and feeds. I mean, x86 is a perfectly good solution. You've got everything in software, and you can do whatever you want there.
Well, don't you, at some point, though, the data center is going to continue to innovate because they can do this in software and they can bring applications to market.
Exactly.
In weeks instead of years, going to the foundry. At some point, the enterprise and service provider can say, hey, where's ours? So,
I started my career writing software, right? I'm always somewhat skeptical when people tell this story. they talk as if software development is this clean, linear, nothing ever falls off the track process.
We're getting into more problems with abstraction.
So I always, there's always thing, hardware, software velocity is always better than hardware velocity, which is true, but I think from an end user perspective, it's a lot messier. If you buy an ASIC from us, it does what it does, but it's baked. You know it's going to do what we told you it's going to do for 99 out of 100 times. Software is a lot messier. And, I think one of the things is, I'm not sure how much customers, the typical end user, is prepared to handle that. I mean, if you're a global 30 financial services company, or you're Google, you can throw dev engineers and support engineers and all this stuff at this. I think the typical Joe Jane mid-market or even a decent Fortune 500 enterprise, I think whether you do SDN or not, I think it may not be the technology piece. It's like, okay, is this the cost-effective solution for us to go chase, or would I much rather buy someone else? I mean, even buy from an integrator, and when it falls over at 2 o'clock in the morning, it's their headache, not my headache.
I've been worried about a variant of that. You get called in because somebody's having a problem, and you find out that somebody talked them into, I'm running controller X with these 30 different plugins that are all supposed to be the sexiest thing alive, and you've got to somehow figure out which one of those 30 plugins has a bug.
Exactly. I mean, that's not
Exactly.
new. We did that in 1999. I was implementing OSPF routers, and having Wellfleet and Proteon and Cisco routers, and none of them worked together. Right? OSPF was a disaster area in 1999. Right? It didn't work at all. Today, I can configure an OSPF protocol, and pretty much it works out of the box. Right? So.
But
what are you wishing for? You're wishing for a decade of innovation in 1 year?
No. The OSPF protocol is relatively simple compared to what we're trying to do with applications running on the controller.
Sure.
OSPF protocol is doing one thing, one and only one, actually two things. I mean, maybe flooding packets and exchanging hellos, what have you, right? But it's a very limited functionality. What we're trying to do with the applications, I mean, sky is the limit, right? So as we develop new applications, we're going to develop new ways how to screw up the network. OSPF was one thing, and it had a certain set of ways how to screw up the network. We worked it out. Don't need to touch it again. With apps, you're going to have new ways. Sorry.
I agree with Omar on what's going to transpire here. We're going to see companies develop software. We're going to move to a software kind of environment because the vendors like Cisco can then iterate. It's a 5-year cycle for new silicon. Okay, that's too slow now. They need to move faster, and the only way to do that is with software. So they're going to be developing the libraries, the subroutine calls, if you will. It'll be a network subroutine call. Give me a layer 3 network that encompasses these ports in my network that interfaces out using this protocol to the rest of my legacy network. And is it composed of, is it one subnet or is it multiple subnets? So it'll be some abstraction layer which is higher than anything I've heard anyone here say yet. But I can see that that's where it's eventually going to go. Is it's going to be, my analogy is like memory management. It used to be I have to do my own memory management for mapping regions of a program into memory and execute them, and then map the next piece in. I had to do that manually when I first started doing software development. With virtual memory, it all happens underneath the covers, and there were bugs along the way, but it's been solved.
That's what I was talking about, that we need higher level APIs with policies, and maybe the first step that we've got in Cisco is the 1PK. I mean, it does have a higher level of interaction with the system than just the
Yeah, I think when you're talking about 1PK, you're talking about foundational element, not packages that are combined with it, or my routing package, my security package, so on.
But it moves up. I mean, if you look at the service sets that John showed you this morning, it's kind of starts to, it starts the process of
it's the foundation.
Abstracting and logically grouping.
Oh yeah, no, it's not a knock on it. I mean, I expect, and to your point, that there will be early, Cisco has a very defined second to market strategy, right? That will see systems integrators and startups, whatnot, fill in that void, and as frankly the market's defined, Cisco put its weight behind it and release products that fill that gap, and we'll go from insanity to stability in that space.
This whole discussion's starting to kind of click for me, because especially when you just said, I just got the higher level API thing, which is the memory management thing. I'm sitting here thinking, hey, we're overcomplicating this, having to talk about all the guts and the details and think about, planes and all that. It is abstracted to us right now, and I don't think we have to go back there. Greg probably totally disagrees with me.
I do.
You're nice all along.
But
But I'm starting to get it. I'm not necessarily saying that's where I'm at, but from the one PK thing, one of the things that you said is the vendors are going to have to differentiate themselves. I think differentiation isn't
definitely.
necessarily going to be that you guys aren't using the same standards, because we've got to get back to some standards, core functionality, so we have interop. But I think you guys are going to differentiate yourself between what your APIs can do and what you allow your ecosystems to do.
Mm-hmm.
I think that's the differentiation, and I think very quickly, if the vendors don't want to piss everybody else off in the consumer environment, that you guys are going to have to come to a way that you can interop.
Honestly, I mean,
Right.
me and Brent were
I
talking about this
agree.
earlier. I fully expect, just same in the cloud side, how the API used to be very, very important for cloud providers, and now things like libcloud and jcloud are emerging to abstract it from. Frankly, you don't have to be that aware if you want to use a subset of the functions. You know, I think we're going to see something like that happen. Everyone will argue about which spec's the best, and you know, someone will get smart and just write libraries that write to all of them. We'll end up using a subset of the functions, but still end up with an existence of, God forbid, functional networking elements that are configure stuff via API.
But what plan are we living on for us to expect all the vendors to agree on an org?
I know, they argue all
We've
day.
got that today. We've got SNMP, right? And I've got no ID list that's from here to across the room. Is that going to?
so I think a better model.
I don't think you can hold that up as a good model.
That's probably not the model I would
else.
choose. So if you look at Ethernet, like it's a defined set of interfaces. You know, you're at the point you can take any two things, even God forbid a dealing box, and an enterprise dealing box, and plug it into something else, and the world's a happy place. But there's still, you know, a lot of differentiation. I don't think anyone would say a dealing box is the same as a Cisco box, is the same as a Juniper box, is whatever. And I think from a vendor perspective, that's, you know, where it starts to become interesting. Is, and I think there are a lot of folks who believe that network is utility and networking is just networking. And I think as they start to roll up their sleeve, they'll start to see, oh, really, there are some implementation differences. We used to joke, you know, Cisco is successful because we drop packets better than anyone else, which is, you know, someday it's, you know, it's kind of silly, but it's kind of true, right? There was some of the implementation details that made this switch better than that switch. I think the other thing from our perspective, and the reason we've talked about those service sets is, if you look at, you know, we had this conversation on Twitter about licensing. If you look at all the stuff people buy from us, and then all the stuff they actually implement, it's like they buy these feature sets and they implement these feature sets. And part of it is because they don't think they're hard to figure out how to get to. I think from our perspective, one of the reasons we think this is all interesting is to take, you know, a lot of the cool stuff that's already in there that they already paid for and make it more accessible to the people that will actually use it, which is not network operators, but developers. So to your point, you know, my goal is we get to a point where a developer can say, you know what, I need a 10 meg pipe that's PCI compliant, that's HD video capable, and you know, make that call through their software, and boom, it's up and running, and the rest of the infrastructure underneath is smart enough to figure it out all the way down to the boxes, and you know, be smart enough for to be able to figure out, you know, on this box versus that box, it's going to look a little bit different.
Well, before we go too far away from the hardware up the stack, I mean, theoretically, this is what the fog is supposed to be working through, is this defined set of abstractions at the hardware layer, right? So some kind of hardware matrix that comes out of that. I think there's a lot of room to differentiate at the vendor side. And this is all guess, because I don't know what goes on with ONF, I'm just assuming that something along
I
those
think
lines.
so too. You know, I'm not following it. You know, I was following the earlier efforts, and it was very difficult to come to a common denominator on what actually the forwarding abstraction should be. Right. So I don't know.
I think the other thing that's going to, I don't know how many people in the room are aware of it, most of the innovation around OpenFlow is happening in the software switching space. So what's been done in Open vSwitch in terms of the extensions that the different vendors and startups have done with Open vSwitch to explore a number of different directions for changing the forwarding model. I think once those, I get an advantage in that I actually speak to not just to you, you know, to Cisco, but I'm also being briefed by Juniper and Brocade and also a bunch of startups who aren't out of stealth yet. And all the innovation in networking is not happening in hardware because all the vendors can't agree to actually do anything in hardware because it's hard, as we talked about, pipelines and silicon and pathways, it's complex discussion, but also because there's a lot of jostling for position and, you know, people that, you know, so we're going to see a lot happen in Open vSwitch, and I think we're going to drive the lessons that we learn from this software switching. So what Nicira does with VMware, now that they're part of VMware and delivers in their software switch, what the different vendors will be doing with Open vSwitch and how they take that to Microsoft or VMware. That's going to drive.
Don't you
what
think,
happens.
I mean, once,
I don't think the networking vendors are in control of the future anymore. I think the application hypervisors with the software switches are taking over the networking discussion. I really don't see Cisco or Juniper or Brocade leading the future of networking right now because they can't agree on an SDN strategy.
But I
So
think that
there's
that's,
a large there's a large community of server virtualization people that is much larger than the networking community, and they're just totally ignoring Cisco and Juniper and all the networking.
well, they're writing software that works on the stuff that they've got right now. It's like, listen, if we can't get anybody to agree on how to hardware forward packets, screw it. We'll just write it all in software and make it work, and then take it to everybody and go, hey, I don't care if you run this on merchant silicon, your own custom fab stuff, or if you go buy a company to do it. This is what we're going to do with our product. Run it if you want, but everybody else is already running it. Deal with it.
But there's a reason when things end up in silicon, right? I mean, we get to a point, one of the reasons the software folks are in charge is because there's not a whole lot of anything that's defined or understood, right? I mean, there's no technical directions and no protocol directions. Everything's kind of up in the air. So it's really hard to spin silicon that'll support the up in the air compute model.
Yeah.
I think as stuff starts to settle down, then we remember, hey, this is why we do stuff in silicon in the first place, because it's faster, it's more compute efficient, and we understand we need to do this, this, and this, and we need to be able to do it as fast as possible.
So you guys are just
Suddenly
afraid of creating more dead product lines?
Absolutely, that's our plan.
Yeah.
That's our next
No, what I'm alluding to is over time, we always start off with a functional feature set. Look at Cisco iOS routers a decade ago. Everything sat in the fast path, and anything it didn't recognize was punted up to the CPU.
Right.
And then over time, we learned how to change to do distributed forwarding. And we started playing DF. So when did the DFC1 come out? Sort of like the mid-2000s in the 6500 platform where we could actually have distributed forwarding tables on each line card, right? That took a long time to develop it. But in the early days, everything was punted through software. So eventually, all these software features that we talk about will trickle down into silicon because it's more efficient to do them in silicon than it is to do them in
Well, there are people who like to laugh because of Cisco Express Forwarding. And it's like, oh, well, that's how routers are supposed to work. Yeah, well, remember, we didn't always know how to write software to make the router work like that. We had to develop that over the course of time.
Mm-hmm.
So don't automatically assume that, the hardware's going to be capable of doing whatever we throw at it. We've got to write software to make the hardware performance. What we need to do. But look at Intel and other companies who are trying to come out with, what I would say is a baseline hardware platform that you can write to that says this is the performance profile you can get. Now, if Cisco or Brocade or anybody else who owns a fab plant wants to go in there and tweak that and say, hey, maybe we don't need as much performance out of this ASIC over here, but we want to overdrive this one over here because we really want to be able to terminate VXLAN tunnels, or we want to be able to, quadruple the performance throughput for the Nexus, the financial Nexus switch. You guys can play with those variables within a certain spec, knowing that the software will support it at a certain level, because we finally figured out how to make those two things mesh together.
Mm-hmm.
Hardware and software playing in concert. But right now, this is a Mexican standoff. You guys have got your guns held to the head of the software people, and they've got their guns held to your head, and nobody wants to flinch. Somebody's going to have to take a chance and say, all right, I'm going to write this, or I'm going to create this ASIC that's going to do this, and you guys need to write software to support it. Or the software guys are going to have to say, hey, we're going to write this really awesome stuff, and you guys have to create hardware to make it work.
So I think,
But part of the insanity, with proactive flow instantiation right now, you can, at the edge and support, you can totally redo how you classify at the edge. You can change your custom forwarding model of traffic engineering, jam it into an LSP and send it on. Properly classifying it with business logic, time of day, workload classification. I mean, you can go down the list right there. BYOD reactiveness in the enterprise. And how hard is that? Fork me off to an isolated path instead of flipping VLANs with SNMP. I mean, it's not like we're asking for a lot on this, just particular sets where we can proactively instantiate flows into it. I mean, ARPs are a little tricky.
Well, that's exactly what hybrid switching is all about, but that's actually the other model, which we call the integrated model, where you could use OpenFlow to install rules into the existing control plane. But that turns out to be a lot more tricky than the ships in a night approach.
Sounds like you got a square peg and a round hole problem. Is, how do I make this new hotness work with the old busted stuff?
So I
Just
mean, I
drain it
think,
into one pipeline.
so I mean, I'd argue at least what we're doing with giving you platform APIs is our approach that here's unlocking or opening up pretty much anything you do with a silicon. I think you got that you got that from So from our perspective, and we talked about this a little bit, we're taking features that were before hidden within the innards of the operating system and exposing them so folks, if they know what they're doing, or even if they don't know what they're doing, can access them directly. So, we've opened it up, we've talked a little bit about some of the applications that are being built. We'll see what happens from, we'll see what happens from the software front. I think there's a larger conversation that needs to happen, within customer communities is, differentiating what we can do and what we should do. Can we do our own packet classification? Absolutely. I would question the number of people in the industry that really know how to write good packet classifiers and should roll them out.
It'd be really interesting to see, obviously we can all argue about theoretics, except, one or two people is actually doing something. But 2 years from now, as I would assume that Cisco starts contributing, well, they are contributing a lot of code to the, to functional SDN. Look what Quantum's doing.
Mm-hmm.
As I would assume Cisco starts flooding the SDN market with effective code that could be utilized. How much the discussion really shifts from, you're providing me ASICs to people are like, hey, I can reuse this code instead of making my own.
Yeah, so I know, from our field is they talk to customers about 1PK and all this platforms and controllers and stuff. Honestly, a lot of times reaction, okay, this is really cool, but make it do something useful for me. I'm glad I have all this.
Well, a great example.
So you give me a toolkit, and you give me a toolbox. I really need a desk.
There was a demo shown today, which actually solves an interesting problem of how to force certain cloud application authentication flows through a smart proxy.
Yep.
Right. I assume that code would be delivered, and we can all write. Theoretically, anyone could write that themselves with proper skills, time, and capabilities. But as and maybe that is the war between Cisco, Juniper, whoever, is who actually delivers working code. I think that is the war. What am I talking about?
Well, in the end, that is exactly it. But these applications, unless how are you going to do that? I mean, you can go commercial, you can go open source, right? So, who will be providing these applications for free and open source?
Well, free or pay. I don't think it really. I love open source technology that links into really expensive Blinky stuff. I think it actually it's really good for companies, but we'll see.
Yeah, so you either have software companies who are creating these applications, and then somebody's got to pay for all that development, or you've got OpenFlow, open source software, where these apps are actually open source, but somebody's got to fund that too. And who is going to do that? And I would think it's either the vendors, the hardware vendors who want you to buy the hardware, or it's maybe the operators who want you to use their network.
I remember 04, I steered I had a multi-million-dollar network refresh back then. The primary, other than actual functionality of the network, once that was resolved and there were competitors that were equally functional, because I was building a 3,000 node iSCSI network because Cisco open sourced the iSCSI initiator, that actually moved my decision that way. When I think back to the .com, I shifted from Compact to Dell because of their Linux contributions, specifically their integrations of their RAID array drivers and remote administration cards. And today, as working with OpenStack, Cisco's contributions to Quantum and the plugins that lock into it, as well as their contributions to Puppet deployment, drive my decisions in that direction. I think absolutely that open source contribution does drive hardware choice.
And you will probably see similar things happening in the controller world. You will see that in the application world as well.
Yeah.
So kind of moving up the stack. Yeah. Now, innovation happening in the software. I mean, that's also true. And the thing is, if you really want to get performance out of it, x86, I mean, it starts assembling microcoding in the chips that are being used in hardware, and to really get performance out of a platform. You need to understand what that platform is. You need to understand the DMA. You need you need to understand the NICs, what it's using, and all that stuff. I mean, just look at Nicera's STT. I mean, that's a really nice kind of a thing where hardware actually drives software switch development, right? But what I wanted to say is, with these overlays or kind of innovation happening in the net in the edge, true for features and for kind of basic development velocity of innovation, but you still the network in between is not transparent, right? I mean, there is things that happen. I would just go back to what Omar said about that we're dropping packets better than anybody else. When you start dropping packets, you actually need to know where and how and what is causing the packet drops. If you have a problem on this path, would it be better to send them over that path, what have you? So this kind of a thing that we can now just treat the network as a black box without, everything is going to be hunky-dory and we're just going to fly over it. I don't think, well, that's another kind of a brave new world into which we're entering, and it's probably going to be different than
Do you
what
think
you
so?
think.
Well, I mean, we do that today with MPLS, right? I don't see how a VXLAN tunnel fabric is any different to an MPLS.
If you have packet losses or what have you, I mean, you've got tools to actually develop that, and they are built into every device on the path, So maybe in the end, the standards are being developed or will be developed in that fashion, where overlays will be able to work in concert with the underlying network.
There's extensions in some of the proprietary forks of OVS
Absolutely.
that are already doing that.
Absolutely.
Right? But I mean, the challenge that we have with OVS today is that although there's a common code base, everybody's forking OVS.
So you see what you were kind of talking, what you were saying about the hardware vendors, you actually start seeing in the software as well. I mean, you've got different vendors in the software world that are jockeying for positions, and they are forking the code base to
But that's
suit their
innovation.
needs.
So that's the ability to take OVS, fork it, trial a feature out, and then push it to market and see if anybody's willing to take that on. Is a faster innovation cycle than we're used to in networking.
Oh,
And
I
think
agree.
that-
Yes.
And that creates some of sort of the common misperceptions, which is, we don't know what, we don't know. People have been saying to me, we don't know the use cases. We can't see what we'll use OpenFlow for. Nobody can give me a use case that I can invest money in. And then on the user side, they're saying, you can't use this technology because it hasn't been, there's no standards or there's no RFCs or there's no. It's just because networking has been stagnant for so long, like a decade of complete non-innovation. So we made OSPF have not so stubby areas. Woo.
We got totally not so stubby areas.
Yeah, totally not so stubby. Wow, that's a total innovation there. How much innovation have we really put into the network in the last decade? So as consumers and in the development side, we have to sort of accept the fact that networking can change radically, even though it hasn't in 30 years, and certainly not in the last decade, which is really what we need to focus on. The market sort of stagnated in 2002, and it's now 2013, and this is the first cycle of change, and there's a lot at stake, because for the large vendors like, for Cisco and Juniper and Brocade even, this is either a chance to lose a position or to advance in a position in the marketplace as there's an innovation gap that has to be crossed. But there's also a chance for other players to enter into networking, because the software switching can rotate, on a quarterly, 6-monthly cycle, and introduce features and change very quickly, and change the face of networking.
But I think there's a pivot point there which we haven't reached yet, which is the risk of doing nothing right now
Yes.
is relatively low. And I know it's good to see all this innovation, forking, and that kind of stuff, but to some degree that scares the hell out of people because they don't want to choose an evolutionary dead end. It's like if you look at anything like DVD versus Blu-ray or whatever. A lot of people are just going to sit in the, they're going to sit on the fence until it shakes itself out because they don't want to collect, a huge collection of, HD DVD discs because they can't play anymore. So
That's where software
Yeah.
Software routing and software appliances for me takes away all that risk. I don't have to spend money on expensive hardware. I can deploy some software, and now I can innovate over that
Well,
software.
we still don't have any tools, support, training, all those things. You know, once you get to the point where the market looks like it's starting to coalesce, is when things will start accelerating, because it
It's
starts to.
it's a typical crossing the chasm
Yeah.
story.
Yeah, it is, but the thing that makes software appliances different today is where I'm actually reducing my firewall appliances and my software-based load balancers to functional primitives, to the point where I actually don't care which vendor's in there. So whether I'm using an F5 load balancer, or whether I'm using a Stingray, or whether I'm using a vShield Edge, right? I'm defining the same feature set for all of them. I'm not using any of those other features because I don't want them anymore. Right? Because I need to have a software controller or an app store or some sort of application that says make load balancer. Click. That's what you
And
get.
that's exactly what I was talking about.
Right? So I can do that in software. I can do that today.
Right.
I don't want all these fancy features that, my personal view on 1PK is it's all very nice and very good, but it's useless. I'm never going to develop to that API because it's got 50,000 different pieces of function. I only need a bunch of core functionalities that exist to do with forwarding from point A to point B, because I don't have the time or the inclination to develop a portfolio of controller applications that expand into all of those functionalities.
And I think, okay, so there are two levels here. Yeah, there's a lot of functionality, but that's a lower level. The functionality you're talking about with the firewall is up here. It's much higher than the functionality that 1PK is providing right now. In between is a set of libraries that take this, punch the button and give me a firewall, punch the button, give me a load balancer, punch the button and give me a layer 3, layer 3 network sort of thing. Relies on the low-level stuff down here happening. Okay.
Well, also
And there'll be a set of libraries that go in between the two, and so you will get what you want, but it'll take a while for that innovation to occur. It's not going to be tomorrow.
You have 50,000 APIs, but you may be using 5 for them for your applications, and that's all that you need. But the other 49,995 are there for other application developers who may use them for something else. It's
I don't think they will.
It'll shake out.
I think SNMP
it's like calls
showed you-
into an operating system. I mean,
I don't
different
think so. I
apps
think the lessons
do
from
different
SNMP
things.
were everybody ended up just coming back to the interface 2 MIB, and that's all we ever use. Cisco's got a metric ton of SNMP proprietary MIBs that nobody uses because it's pointless. They change all the time, they move around, you can't get a capabilities exchange, you can't roll them back, you can't write to them. And I think that for remote usage of the networking, we won't ever use all of these, 4,000 RFC features. We will just end up coming back to a core functional set that we actually need and can make something out of, and that's all we'll ever use.
I have a data point that
I
I'd
would-
like to adduce, because I've been thinking about this issue, although maybe in a more primitive way. The piece I've been seeing is comparison of the distributed virtual switch with 1000D. And networking people that I'm dealing with are just totally not picking up on this is your network footprint. And meanwhile, the server people seem to be the decision makers, and to them, the DV switch is overly complicated. They're not interested in 1000D, and now I'm getting crap from a VMware guy who's saying, hey, VMware's got parity.
I'm with you,
This is
right?
point of view.
So I'm doing that now. I'm choosing vShield Edge and vCNS and VDS because I don't need more than that.
And I think that's inherent in the nature of the beast, that to some extent we have to give up all the bells and whistles that have been competitive edge in order to get some commonality of the API and so on. And there's this debate around good enough, not in the sense of crappy switches with, I won't name the vendor, but in the sense of enough features to get the job done for your
So
average
basically
site.
what you're arguing for is a smaller set of APIs that would be kind of more generic and useful.
Yeah, and
I think there'll be a fundamental
what you're trying to do
set.
is embrace the innovations of 30 years of product development
Yeah.
and give me those. And you
I
can
think what you'll
perform.
see is you'll have a fundamental set that will have longevity because they actually get used by the majority of people. The other
Yeah.
ones will start falling off because the developers won't want to maintain them
Nobody wants them, right? It's just
because
like
they're not used.
at the end of the day, there's a firewall. Like if I pick a Juniper or a Checkpoint or a Cisco firewall, but how many people here have ever configured anything but a layer 4, source destination, with a TCP destination port in their firewall other than that, ever. I've seen entire firewalls that, mission critical businesses, and there's all these features in there to do application inspection and DNS security, and nobody even knows that they exist. We don't need firewalls with all those features. We don't need routers that do fancy routing and OSPF to BGP redistribution and, packet replication in silicon. We just need switches that do very simple path forwarding. And I think that was the innovation behind OpenFlow, was that we could reduce networking to something that's reasonably primitive so that we could actually make something out of this. And then we can continue to innovate in the years to come.
Yeah,
We
but
don't have to embrace the entire legacy of 20
maybe,
years of networking.
but to some degree you're moving stuff around. So you're having very low-level primitives, and to be able to do complex things, you're moving that up to the stack. So you're saying, I'll take a bunch of simple tools. I'll take, I'll get like 5 different Legos, and I can build anything. And that's true. I think at some point you start to build more and more complicated things, you're going to start to want more sophisticated tools. Right, I started golfing, I had like 3 clubs, that's all I needed because I could barely use those. At some point, I started adding clubs because I start to see a use for that. From our perspective, it's not, we came up with 1PK and all these interfaces because we have 11 interfaces. It's the stuff that we need anyway to go build an operating system. So think, what the heck, we'll turn it over to folks and they'll find things to do. We're not saying, hey, if you want to build something, you have to link to these 18 libraries to be able to build an application. You just want to build the security set.
So, Omar,
build the security set.
are you saying that as a company that actually builds network applications, that Cisco, having experience building building network applications, actually uses the libraries to build applications? And that other people, when they start building network applications like Cisco, may actually want to use the same interfaces that Cisco does building iOS?
Well, isn't that the point of 1PK? This is the same solution set. It's the application, it's the interfaces that are built into the OS. That doesn't mean you have to use all of them every time you want to do.
Well, no. So I'm actually agreeing with you is the
Okay.
point. So, Cisco makes complex networking stuff, and they use all this stuff, and they're exposing all this stuff that they use. And if you want to build something as cool as the Cisco stuff or the Juniper, whoever, that you probably want access to the same
So there's
APIs.
I think there's 2 approaches here. One is the approach that Cisco and 1PK have taken, which is to say we've got all these funky features, COS and MPLS and all of the 1PK map. So we're going to give you all of that, and you can do everything. And I think most people are going to look at that and go, I don't even know where to start. Walk away.
Most
Right?
people
And
look
fail to-
most people look at a router and say, I don't know where to start.
Okay, but the flip side of this would be for the vendors to say, I'm going to build an OpenFlow switch. It's going to be reasonably cheap to acquire because it doesn't need all of this stuff. It can be a very simple cut down, and then start to innovate on that and set the expectations with customers to start rotating that hardware out every 2 years.
Well, and luckily nothing is stopping that from occurring, yet it hasn't occurred yet.
It has. There are switch vendors out there who really like Pika 8. Pika 8
PK,
uses
it's
open-
great. They're, if you look at JR Rivers and the cloud scaling guys
Yeah.
and what they're doing in that space, and you can go look at some mega data centers down the road and see some very specialized companies that use it. But go walk into the healthcare clinic down the road and go look for the PK8 operating system on Quantum Western gear. It's not there.
But we're expecting, we're really legitimately maybe a year into talking about this seriously, and probably like 3 months talking about this seriously, because last year this time we were crazy and stupid. We were stupid academics or whatever. But I mean, we're going to keep revisiting this conversation for the next 10 years,
Absolutely.
unless at some point we say, okay, we're going to standardize CS 101. We're going to agree here, and we're going to create abstraction layers, because there's so many more important problems that we should be solving.
I
at
don't think
application
anyone's
layer.
disagreeing that.
That's the risk versus CISC debate, right? I mean, we went to a risk architecture, and then in the end, actually, CISC kind of won out, but incorporated all the risk principles with it.
Right.
So
So it's not a gamble when some of us that believe in this, because
Yeah.
we've got
And it's
20
not a
years
zero
of
sum game
computing
either,
that's
so-
already gone this path. I mean, people freaked out when you started virtualizing on
Absolutely.
99 the server.
absolutely.
We're all going to lose our jobs. Well, no, you're not.
No, but I mean,
You're just not going to swap us.
I just wonder why Cisco hasn't shipped a switch in the OF in the simplest cut down version, supporting OF 1.3
Or 1.0.
or 1.0, and just say, try that.
I have a question around that, because Omar, earlier you said that everything in the life cycle of Cat and Nexus is going to support OpenPK. And from what we said earlier, 1PK, And everybody said earlier that one PK has OpenFlow, one whatever in it,
So we
right?
have, so we have the ability to turn up OpenFlow agents on switches, right? So the way 1PK is built is we have a pluggable architecture, so we can add interfaces into it. So 1PK, other protocols as they come about,
So
they
what-
plug into it.
So what I take away from that is you go back through and you enable this through the 3850 and whatever else. These are now OpenFlow enabled switches.
Yeah, you can, and with the things we talked about, we talked a little bit about this with our current announcement, the announcement we just made, is we're starting to roll out OpenFlow enabled switches. We had a OpenFlow enabled 6500 on the show floor at Cisco Live in London.
Yeah, but I think that what they're getting at is what Greg and Brent want to say is that they don't want Cisco to OpenFlow enable existing switches and retrofit them. They want Cisco to release just bare bones hardware. Like, if you're going to build a pickup truck, you don't take a chainsaw to a school bus. Build a pickup truck. We don't have to want to cut away all that other stuff that Cisco's put on top of switches for years and years and years to get to a packet forwarding engine that accepts instructions from an OpenFlow controller.
I'm showing
Early
an
on, this
example just to try to think about this, because I'm sort of agreeing with, I think there may be some violent agreement going on here.
We're all right here. We're all right. We're here.
Heaven
And the
forbid.
example I'm going to give is I see so many sites with F5 load balancers that they paid hundreds of thousands of dollars for, and they could have bought a $20,000 box because all they're doing is destination nav. They're not using any of the HTML rewrite
Exactly.
functionality. And so that, to some extent, says, maybe the missing piece here is marketing and persuading.
Well, the missing piece is marketing.
Yeah, well, persuading people that they need to spend money for all this extra value that you're not
I mean,
actually going to use.
Well, as you say, I mean, you know, in the vCloud 5.1, the VCNS toolset now includes a load balancer, a very competent layer 4 load balancer, right?
So now, and there are all these people at the low end that I've never heard of, but more and more companies jumping in, and
Yes.
it's like, why would you buy one from them?
Okay, so the flip side of this is that automatically starts to make a bigger load balancing market because VMware is giving a simple load balance. So one of the things that Gigamon's done, so we talked this morning about the span and the 1PK being used to do port analysis and, you know, creating fabrics of port analysis stuff. That's actually made the market for products like Gigamon bigger, not smaller. You might think that it actually took away their core business because now you can just use standard switches. But as long as they stay ahead of the curve and offer the fancy features on top, and then customers can start off with that, building these span fabrics that we've never had before, and then suddenly say, actually, I need more than this, and I need to go and buy this custom kit. I think the same thing happens with OpenFlow. We will start with simple OpenFlow-enabled primitives that we can do basic stuff, and then there'll be a group of people who will say, this isn't doing everything that I need to come up to the next level of feature set, and that will be more of what we have today, which is these 20 years of libraries and functions that nobody uses.
So I'm not sure I agree with that. So I mean,
Yeah.
we've talked about the fact that we have a bunch of customers that have stuff that's up and running. They want to be able to do OpenFlowy stuff, SDN stuff, but they don't want us to have to rip out what they have that's already running to,
See, I think
to be
that's
able
a
to do that.
fallacy. I understand that that's what they think they want, but I think when they try and get down to it, I think they'll fail.
Well, we will see. Our strategy is to enable customers to be able to look at SDN as an incremental adoption model. They can use it where they want to, and they don't have to use it where they don't. For the most part, I think most of our customers have stuff, it's up, it's running, it gives them the features they're looking for. So certainly in the enterprise. Education, service provider, different conversation we have with them, they're in a completely different space with adoption and maturity and the use case and those kinds of things. So for what our customers asking for, hey, I've got all this stuff, I'd love to be able to do one, you know, I'd love to be able to have programmatic control, I'd love to be able to have OpenFlow access to this and try out a couple applications, a couple of workloads. That's what we're delivering. You know, if we look at where the market goes down the road, you know, we'll see.
There is a pricing market from those who want $0 products to those who want best of breed products, right? I mean, we all do that, we all buy products. Our customers buy products the same way. There is already a market today for very low price switches from Dell and Netgear and Quanta. Customers put them in their network and, you know, they're happy with it, Why is SDN changing that model? You are getting a cheap switch anyway today. How is it different from with OpenFlow?
You have the customer relationships, and you're losing customer relationships if you don't.
I don't,
introduce-
that's not true. I mean,
Well, it's
I've talked to
It's
nearly
early.
300 customers,
It's
right?
early, yeah.
And I've talked to 300 customers in the last 6 months.
Yeah.
That's not true.
No, you've taught them over 20 years that they should only buy expensive
Doesn't matter.
stuff,
I mean,
right?
at the end of
They
the
don't
day,
even know how to buy
customer-
cheap stuff.
at the end of the day,
Until they make the
customers,
break, but when they make the break, they don't want anything
see,
else.
customers don't look at it in black and white fashion. They look at what is it going to cost me. First of all, I have to run a production network. Second of all, I have to worry about talent, right? Third, I have to worry about silos, people and processes, infosec policies, operational details, right? All of these things they have to worry about.
Okay.
And so when
as
they
soon
put
as you
all
get
of
into-
that
As soon
together,
as you get into a cloud environment, all that breaks down. That's all yesterday's. That's what customers are telling
in
you.
fact,
Because they're still organized like old style businesses.
in fact, OpenFlow purists are saying that OpenFlow may not be right for data center. I mean, one day you say, this is going to commoditize switching. Next day you say, hey, this may not be right. Third day you say, hey, it's not going to be meeting all the use cases. I mean, you look at the progression of where they're talking.
So wait, when did this all happen in the past 3 months? 'Cause these
Yeah.
are some conversations I
Yes.
missed, right?
I mean, Churchill Club,
So you're
right?
talking to a room of
That-
consumers.
I mean,
But that talks exactly though to the point about buying something that does more than you need, because if you do get the stripped down bare bones, talks OpenFlow, one of those, chassis that does nothing else, and then you decide that
That's
actually
funny.
OpenFlow is not what we want,
That one.
you're into
you're,
performance territory.
you're screwed.
And I
So
think
what?
that's- I think that's the
Hang
same
on,
thing
hang on.
that-
So what?
Well, okay,
If it only cost you $5 grand, or if it didn't cost you
It
$5
costs you,
grand,
it costs you 10 times more to deploy that switch, operate that switch, manage that switch, and do that. It's too costly to rip and replace.
But that is not, that's not grounded. Today, all I need is a switch agent that's gonna expose, that I'm gonna be able to do proactive matching in, that doesn't cost me a dime. So this idea of ripping and replacing is crazy. If it doesn't work, it doesn't work. But I've got tools to peel traffic
No, it'll
off.
work. It's like, it'll work for a couple use cases. I get excited, I deploy it. Now I have to do 10 more use cases. It's not going to work. It's not working. Now I'm in trouble, right?
So now so we innovate via protocols through the ITF and
There-
IEEE and
Yeah, there
the
is
other
no single
2000.
protocol.
You missed the early
There
part
is
of
no
this.
single
We need to
protocol
regress.
in last 30 years of networking that I've known that has met customers' use cases. Customers need switches that are multi-protocol.
Right. And why is that? Flexibility, right?
Flexibility
So when we start
and the
talking
use
about
cases.
flow forwarding fundamentally starts integrating application awareness, right?
But you
Show me
are,
application awareness at layer 2, show me application awareness at layer 3, show me application at layer 4. Combine all those things together. Give me a protocol that I can do that with.
But ripping and replacing a switch is trivial today, right? I'm puppeting most of mine. So for me to pull a switch and put a new one in, I just put a new puppet in. It takes 15 minutes. Not a big deal.
I'm not sure that, and there are customers who will do that.
Yeah.
I'm not saying there is a spectrum from those who want the products for free, open source, right, to people who are ready to pay best of breed.
But if,
And we will serve a set of markets where we think it is
I'm not sure that best of breed involves a dump truck full of crap. Best of breed might be a Ferrari that roars down the highway because the engine is stripped down and it's bloody uncomfortable.
I'm happy to have a difference
Well,
of
what about-
opinion, right? I mean,
Yeah.
but
you see, right now, OpenFlow is a fantasy you cannot counter because it's promising everything, and there's nothing in production, right? So that's a challenge. Once it goes into production, once these things hit rubber meets the road, we will see what works. It shows, and if it's the promising next best thing to since sliced bread, Cisco will have to adopt that. I mean, it's not that we are not adopting it. We are adopting it, but we are doing it in a hybrid manner, which is what you don't like. You want a clean slate, right?
No,
It's
no.
not a model that we are going after right now.
That's right, yeah.
So I have a
but-
question. You just said that OpenFlow is a fantasy, and I'm coming at this totally dumb. I'm not trying to bait you. Is 1PK in production anywhere?
1PK is in POC. We have not released an FCS platform or GA platform today.
Okay.
So
is it in production?
POC.
Is it in pre-production at
It
a
is-
client anywhere?
It is in proof of concept.
Okay.
And it's as much of a
Same thing
fantasy
with
as OpenFlow is.
So-
Same thing with OpenFlow
No,
today.
'cause I can
At
do
least
So
on
again,
Cisco.
I wasn't trying to bait you.
No, so
But
yeah.
this is a discussion about a new field
Right.
we're in.
Okay.
So for any vendor to attack an open standard or another vendor's platform, quite honestly, makes you look very obtuse.
No, let me answer that, right? So I think your point is spot on. So what is 1PK? We should understand what 1PK is. 1PK is I have my existing switch or router, I'm making it programmable. That's all I'm doing. I'm not changing the architectural paradigm of slicing a networking element into two halves, a data plane and a control plane.
Which I think is really good for dedicated Cisco clients. I think what has been laid out for us today, if you are a Cisco shop, is beautiful. Because it goes all the way down through the existing Cisco stack of what's still supported, and then goes into the future. But there's a new paradigm coming in networking that this doesn't address.
Hold on though. Let's go back to your earlier premise. You talked about proof of concept 1PK versus OpenFlow. And my argument is OpenFlow is a new protocol, right? We don't know what security implications are, what survivability implications are, what scalability implications are.
That's
right.
fun.
All of
That is
all of
outright
those.
fun.
It's
That's
not.
fun.
It's
That's
not.
just no.
It's
That
not.
is absolutely
There's a
fun.
man in the middle attack.
A dog-
Hold on, wait,
Right,
let's
so-
replace this with Lisp.
Hold on.
I don't know what the scalability, the security implications
And
of
it's a
this.
new
I mean, come
protocol.
on, let's be real here.
No, it's a new protocol. Any new protocol will go through maturation cycle, right? We have to accept that. We have seen this with voice over IP.
Well, no,
And
some of
it's
those
gonna take
things,
time.
some of those things you can quantify specifically though. The protocol's right out there in the open. You know what it is. You know how the controller and the switches talk to one another. You can see all those things. So you can't just say we don't know it's a new protocol. Well, there it is. The spec. You can read it. You know it's
But
implemented.
that's true for every protocol that's submitted in ITF. All I wanted to differentiate here is, and we can debate whether or not it meets all the security requirements or not, or whether or not it creates new attack surface, right? I don't know. If you think that you have the answers, that's great.
No
But
worse than
going back to
protocol.
1PK and OpenFlow, that's where OpenFlow is a new protocol. 1PK is not a new protocol.
Okay, cool. So
It's
let's
simply an API. right,
I'm
of
not
existing
I'm not
capability.
arguing your point. I just, again, I'm not a VAR, I'm a client. I wanna keep this conversation very honest.
Yeah.
So when we say.
And so I hope you would
So let me
you would be
talk a
okay with a healthy debate, right?
So let me talk a second. So 1PK opens up the developer package that Cisco uses to crack iOS and Nexus and everything else and add new features and manipulate things. You guys never break things and introduce bugs and security problems in your platform. You've never done it. So, too, on top of that, if you're now giving me that stuff, odds are I'll never do it. That being facetious. We don't know what the attack surface is, what the scalability surface is, or anything else around a single 1PK platform product because it hasn't been done yet. And arguably, somebody said earlier at the water cooler, coders don't do it right. I think it was Ethan, and I'm sure I'm misphrasing it, but coders don't code in perfect, zeros and ones and in right order. Somebody's gonna make bad code. So to go down this path and say that 1PK is bulletproof now, you are setting yourself up to catch a bullet. I think you should be very, very careful with that.
Everything you said applies to
OpenFlow as well.
OpenFlow.
I'm not arguing that,
So-
but you
so
can't take a holier than thou
No,
approach to
what
it.
I'm saying is there is an extra caution that you need to take because you are looking at a new architecture. You are decoupling the control plane from the data plane. This is not something that we have done before.
handing 1PK to people who have never developed in Cisco iOS or Nexus.
We've had a decoupled control plane for 20 years. Look at it, I'm right here. Who do you think has been designing the networks as a control plane?
Okay, let's get things back on track for a bit. So,
Thank you.
Can I throw one
Okay,
thing?
make
So,
one point.
I think where we need to get to, forget the mechanism, right? I think that's the least interesting part of it. I think the reason we're here is, but talking about this is because it has opportunity to possibly do it. Probably not gonna be here in 10 years, but I think it's enough to get we need to get to the point where we can run programs against some function that has entire topology across a heterogeneous network environment. If we can't say, here's the topology of your entire framework, your entire network, including elements that aren't even necessarily network, I think we're missing. But we've got to kind of lift that topology up and say, here's what we're going to run against. I mean, that's where I think we'll get innovation as opposed to.
sure, so that means that
We can't go to the foundry every time we want to innovate.
So I think we can all agree on some of the endpoints around programmability, that being one particular use case that folks are looking for. I think we can agree that there are a couple of different mechanisms to get there. And I think the flaws or challenges for both of them, whether it's 1PK as a new set of capabilities that people have to get used to, or 1PK or OpenFlow or Lisp as new protocols that aren't necessarily fully understood, I think we can agree.
I was bringing up list as just
I know
as a
that's
point to
fair-
an argument. I think it's awesome.
It's a
but-
fair analogy.
It's a
right?
new protocol. I mean, you know, it'll go through.
No, I was just trying to shut
and
you
it's
down,
fine, that-
honestly.
We should apply the same principles, right? It's not that OpenFlow is a.
Okay,
a
so I have a talking stick.
You're not going to win that one. The
So-
OpenFlow attack surface is 1/20th the attack surface of 1
Okay.
Yeah, we gotta shut Greg down. Yeah, let's check in our
If we're gonna do this-
testosterone and check out our
If we do this,
brains.
I can get the tray of cupcakes back in, we can just throw food at each other.
This is the war.
I think the challenge, no, not giving them weapons. That's not helpful. You know, so I think the point where we can have a healthy debate is the rate at which we can adopt, right? So I think it's scary, we shouldn't do it as one end, which probably isn't all that realistic. It's ready for prime time, you should move your everything over to OpenFlow and whatever you can, get through BitTorrent is probably also not realistic. Somewhere in the middle is where we are. And somewhere, I think the answer is different for different people. I think for the most vast majority of customers that we talk to, they're very conservative about adoption. They think this is really cool, but they also want to be able to move in a progressive way where if it does fall back, and this is kind of one of the things John talked about, you have a safety net. At the end of the day, from our perspective, we think the value is you can go hog wild with the one PK, the OpenFlow agent, you can go hog wild with OpenFlow, but if crap falls apart, you have the existing environment that you can always run with, right? And you can adopt in a way at a pace that makes sense for you.
But that's really here today, right? I mean,
Agreed,
don't
that's
act
what-
like you don't know this. You can fail open, and I absolutely want to fail back to existing protocols.
And we're
right?
not saying it's never going to, it's like the conversation
Well,
about
I do
physical
that
versus
today.
virtual versus cloud, right? For a given customer, their mix of workloads across all three are in constant motion depending on risk level and evolution of technology, those kinds of things. It's going to be the same kind of thing. Maybe it's 95% on a classic control plane, 5% on a programmable control plane today. A year from now, a month from now, depending on the tools, the developers, the industry expertise, the maturation of the protocols, technology, it could be completely inverted. 2 years from now, 10 years from now, somewhere, right? I think that's our perspective in terms of why we haven't shipped a new switch that's a pure OpenFlow switch. Because that's not what customers are looking for. They're saying, there's this crap I already bought. I want it to run. It's make me able to do what I want to be able to do with the stuff I've already paid for.
I have 2 points. One was that my thought example of the F5 was people were really good at ignoring the parts they're not interested in.
Mm-hmm.
So I think we could train Greg.
He gets away with it.
The second,
His wife tells me that we actually can.
the second one was, for some reason, I'm thinking Q-Fabric when you're talking about fallback plan.
That hurts.
That was just mean.
But I think at the end of the day, if you buy a bunch of Cisco Nexus switches, right, and you have all good intentions of OpenFlowing the world, at the end of the day, if that completely falls apart, you have a set of baked-in functionality that works. You're covered. You tell your boss, you tell your lines of business, whatever you need to do, you've got a working network. If you can get the others, as you get more comfortable and build up expertise and be able to take advantage of whether it's 1PK or OpenFlow or whatever, there's a transition point, there's a migration point. I think the thing most customers are looking for is to have some control.
Well, but that's my
Over
point
that.
about
Yeah.
Q-Fabric. I'm not trying to slam Juniper. It's just, I see it as having a real challenge on the sales front.
Mhm.
As in, if I don't like this, or if it's got a nasty bug, what do I do?
I still think it.
I wanted to say something, since Brent asked me. The thing, the OpenFlow, I think the hardware, as Martin Casala even said, right? Hardware, the number of entries you have with Trident product, or the Broadcom ASICs and things, are very small, right? It's a 750 entries, full match, and 1500 entries, L2 only. If you look at it, that's not even a rack of servers, if you put it in a data center. So, can you build interesting applications, like maybe like a matrix application or a big tap from Big Switch, for example? Yeah, you can. But I think, I don't think forget about the protocol being mature or the controller being mature and all that. It's a secondary order of business. The first order of business is the hardware does not scale enough today to do anything interesting.
No.
Well, you can do some things. I'm not saying you can't do anything, but you do some things
Distributed on the edge, you can start.
with the virtual networking you're saying, right? I mean that.
I'm saying hardware on the edge.
Mhm.
I've got 2,000 switches, right?
Sure.
So I can do a lot. That's a lot of entries, and
Well, I think
combine
that,
all that on the
Capital-
edge. Aggregation is a problem,
sure,
but I don't really need an aggregation today. I need to throw it in an LSP or whatever else.
sure.
Aggregation's occurring in the hypervisor anyway.
Uh,
So for me, I mean, the whole access ladder, the more I'm considering where I'll be in virtualized networking or in cloud style networking in the data center, and I think this will also happen in the service provider, is I won't do networking in hardware, I'll do it in software. So I think Open vSwitch heralds the way. So service providers are looking at NFV, network functions virtualization.
Mhm.
They want to munge in software, not in hardware, because they need to be able to change that. So if there is buggy code or if there is something that isn't working the way it is, I don't have to respin my hardware platform, I just pop it up to an Intel server and run the software. That's more likely the way, and I think the innovation around OpenFlow is going to happen in edge switches, in software, in hypervisors, because the networking industry, and I think the more I talk about this, the more I'm convinced this is, the longer we stand in denial that networking can't, we have to have 6,000 RFCs of features in silicon, then the less we're actually going to meet the requirement, which is just to support less functions. We don't need all of the stuff that we do.
Yeah.
And I hate to say it, and I actually agree with Greg here, though. Well, so like if you look at like the quantum design sessions, right? People are doing software defined. It's not OpenFlow at all times, but it's all about service insertions into networking topologies, right? And that's where all the development's going. And those same service insertions and the same ability to insert service controls or security controls, load balancing, acceleration, whatnot. We do want these on our physical networks, and I do agree with you. The point of a service provider inserting value-added services they can pay for in a cheap and efficient way.
You look at the 3945 we saw earlier today.
But-
If you put a 48 port 10 gig switch in that, and then and one of those above it, and then ran a hypervisor, and you just punt everything for a cache, video content, media server, local authentication, antivirus scanning engine, what have you achieved? You've just given yourself a broadband platform world class.
Well, but I think that is what I expect to see. And we can argue about how it's going to happen. There are services which are being developed to integrate into these virtual switching layer, whether that's virtually accessible in a hardware platform or a software platform. But these services are software you want to buy and want to use, right? And we can argue all day long about which API they connect into, but the reality is they're connecting in there. And eventually, and most everyone's probably not going to be writing that software, and I'm guessing Cisco will be selling some of that software, and Juniper, and HP, and
Yeah.
right?
Well, but I think the fundamental differentiation there is open source versus standards. So, you guys you've got an opportunity to stay ahead of it, and if you don't, I think the quantum-like fabrics are going to...
I'm not sitting in Microsoft or the 1KB team's design meetings, but I'm there in the quantum design meetings, right? This is my own experience. I'm sure it's happening on the core pay stuff.
It's all
So-
protected under GNU.
So we had a really good conversation yesterday on packet pushers, and I'm not going to give that whole thing up because I want people to listen to that. But one of the things that came out of that, and again, it comes down to what your use case is, what you're going to need. People who are pure Cisco ecosystem people doing the standard enterprise are going to do fine on 1PK and the structure you build out. Greg's use case is totally different. Brent's use case is totally different. My use case is totally different. What we're going to do is we're going to find our way to the use case that serves us. I'm going to find the products that do mine. For me, that's going to be a mishmash of vendor X, Y, and Z, making them work off of standards and then a couple specialized pieces of hardware. Greg's probably going to go open standards if you haven't caught on to that yet. And Brent's figured it out.
I don't get caught up on open standards. I just get caught up on. I'm not bothered whether it's IETF or IEEE or open source.
But it's what meets your need.
Yeah, as long as there's enough people running behind it, that's all I care about, and everybody can use it, right?
Mhm.
I'm not caught up about open standards or RFCs.
That's
or,
right.
just so long as there's enough momentum behind it, that's all I want.
Well, Josh, you say service provider enterprise data center. So I think what's really interesting there is...
Actually, I didn't. I said my use case.
Right, sorry.
I didn't break it down into an individual model or tier. Because my use case as an emerging service provider is going to be dramatically different than what Verizon's use case as a service provider
Right,
is.
but I think the commonality across the board on all this, if you abstract it a little bit, forget about what the forwarding elements are, it's all it's the edge is the problem. OpenFlow doesn't necessarily solve core. OpenFlow starts giving you more options to do things on the edge at ingress.
So I think, well, one other point is, I think the OpenFlow, even the people who developed it say, right, it's an x86 instruction in the sense that it is specifically telling a device to take a packet from here and forward it here. But you still have to build an intelligence around it. It is the things that we built it through distributed protocols before. Now you have this very primitive thing to do to move it. You still have to build an actual feature or usability function around it. It's not by itself is going to solve the world's hunger, right? Somebody has to come and somebody has to build. I mean, nobody is selling OpenFlow.
But
that,
but isn't that where vendors can make a lot of money on? I mean,
Absolutely.
And no one's saying, I mean, maybe. I mean, at the end of the day, the intelligence needs to live somewhere, whether it's between Greg's ears, in the silicon, in an application somewhere. It's not disappearing. We're not, just because we have OpenFlow does not mean that magically all this other stuff happens. Different customers are going to pick different solutions. Some will want to go the OpenFlow route right in an application. Some are going to want to make it someone else's problem. Some are going to hire Greg. I think that from our perspective, we're trying to give you the most flexible approach. You want to do the OpenFlow thing, have at it. If you want someone else to hold your hand, we'll give you that page too. If you don't want to do anything ever different.
Many customers want to build an architecture that meets many use cases.
Actually,
right, and they want that flexibility.
I think
because
they think they want that, but I don't think they actually.
Whether they think or not, they are making procuring decisions based on that. Right. Now, one can educate that and say that, hey, you don't need all this.
So I think
that's fine, but they're making those decisions.
So I think the thing that's changed in that whole conversation is, I use a Hadoop example, right? So if you were 3 or 4 years ago speccing a network out for your data center, Hadoop probably was not anywhere on your radar. But suddenly you're trying to figure out how to take big data and reverse engineer it into your environment. And I think that's the dynamic that's changed, is the pace of application evolution has gotten way faster. So you used to be able to say, hey, I bought a switch, I bought a router, it's in for 3 years, I don't have to worry about my data center infrastructure anymore. And you can't get away from that, which is why we're having these types of conversations where between virtualization and BYOD and all this other stuff, we're losing control of the types of traffic, where it's going, who's originating it, where it's ending up. So that ends up being the driver that's forcing all this kind of conversation. Why do I need programmability? Why do I need this agility? It's from those sorts of things. 2 years from now, we'll be worried about something else that we can't conceive. For different folks, it's going to look different ways.
I mean, instead of OpenFlow, what is the thought process on OpenStack or Quantum?
So,
He's
isn't that really where most customers' focus is? That make it simple for me. I mean, automate this.
most of the focus in Quantum right now is in service insertion and plugins to multiple different switches, OVS included. Cisco's Quantum networking plugins at MVP, but most of the focus is in service insertion, right? As well as dealing with, frankly, basic problems like IPv6 DHCP, making certain important services scalable, putting network metadata inside of inside of Melange. It's frankly a complete rewrite for Nova Network. Now, is the mechanisms for a vSwitch distribution of MAC addresses the focus on it? No. It's at a higher level challenge.
I mean, it's still a data center specific use case, right? I mean, he's talking about a lot of use cases that are beyond data centers.
Yeah.
But I think conceptually the model is, okay, I've got a programmable stack.
Mm-hmm.
So even from our earlier conversation, I'm out of the business of necessarily twiddling packets.
No, it's about defining and applying policy. Holy crap! This is nothing new in networking.
Yeah, but
it's just how you're doing
it. But at a big
it.
level, you start shifting thinking. We're not looking at an infrastructure stack level.
And exposing that via an API. So if you're trying to build a network application, and it started out just segregating VMs and applying service or instances and applying services to instances, and now you talk about network slicing, right? How do you implement the network slice? It's something a lot of it's taking what's at Amazon and bringing it down into a functional clone of Amazon. People won't tell you that OpenStack is an on-premise clone of Amazon. Look at all the features that come in. A lot of these are implemented through the network layer and can be efficiently implemented using OpenFlow, right?
What I'm saying is, shouldn't we help accelerate OpenStack and implementation of OpenStack into both virtual and physical gear to make automation or provisioning of networks on a per tenant basis, per service basis.
Yeah, please contribute developers. I love the developers that you guys are contributing.
Yes.
Continue. Thank you.
People working on it.
Yeah, I mean 300 people. There's been 770 people, active developers on it right now from 550 4 months ago. Cisco is doing great contributions inside of there, but how it's done, frankly, is immaterial. At the switching layer, whether you implement via the quantum plugins to UCS and Nexus, or if you're using an OVS, frankly, it doesn't matter. What matters is your ability to insert services and emulate the functionality in the largest cloud provider in the world.
So, do we think that clouds should go OpenStack so that we don't have to write to Amazon APIs and Rackspace APIs and GoGrid APIs and Azure APIs?
Well, a couple things are emerging. So one, absolutely, I believe that that people should be looking at providing services to developers similar that Amazon provides. Because the reality is software development is moving into that, into consuming these network-based applications and services, whether it be a database as a service, load balancing as a service, firewall, and whatever. These things are provided by Amazon. OpenStack absolutely is an emerging alternative to that. I think the Grizzly release is a strong beta. Havana in the fall will be a strong 1.0 release. You know, I don't discount and think it's easy for anyone to plug in. But is it valid? Absolutely.
To me, that is a very exciting, development and opportunity to really help customers reduce their operational costs and make things very, agile.
Well, I mean, right now it's just providing services to developers. Now, it just tie it back into the discussion for OpenFlow and Cisco, whatever services. If you look at people that are actually implementing, they're writing plugins, not doing everything in software. I mean, look at Gap, for example. You know, they deployed OpenStack. They didn't write all their storage software on their own. They didn't write all their load balancing software on their own. If memory serves me right, they used they wrote hooks into Cinder from their EMC storage. And their load balancing as a service, I think F5, but they use the code that Cisco sponsored Marantis to write. Right, so they're using hardware for their content for their content switching. I don't know what their routing platform is, but as people are scaling, especially enterprises, they have all this expensive Blinky stuff that works for them quite well. And I think someone made the point of dual purposing, right? So I have an existing network, and then I have these existing innovative features I'm using. And there absolutely is a reason. I think that was one of Brent's requests. Give me something that supports. Right, because I want to have my old environment, my current enterprise virtualization, the Web 2.0 kind of stuff, or DC 3.0, and then this new emerging platforms, whether it's an OpenStack-based cloud or whether it's a segment of my application which uses OpenFlow to apply and control services through here. I mean,
yeah, and I think so. If you look at kind of the strategy that we have laid out, we made sure that there's no technology religion, right? That whether it's OpenFlow or whether it's 1PK,
I could have heard. I swore I heard you say OpenFlow is the devil.
No. I think the argument is OpenFlow only switch versus a switch with OpenFlow and other things. I think that's where the argument is.
Okay.
Nobody's saying OpenFlow is bad. Right? Nobody's saying that. I'm not saying that.
I think I heard it was from you. I heard it's insecure, it's untested.
I said it's not yet at the maturity level. It will go through the maturation cycle,
Fantasy.
right? And we will ring things out.
Fantasy. We can go through Twitter streams.
But we'll adopt if it becomes.
But we are supporting OpenFlow, right? Lots of switches, routers.
Well, I think you've taken the argument away. It sucks to have arguments over religious wars. Go write some code, right? But I mean, there's a demonstration today of actual SDN controlling, applying security policy. Right, of taking 1PK and popping it through this with CSE, right, or through the cloud controller, right? I think stuff like that's where the focus should be. Stop arguing about whether it's valid and write code.
And again, the argument is Cisco support platforms that have 1PK, that have OpenFlow. Customer can choose to turn on whatever they need to based on the risk profile that they're willing to take. What we are saying is that we are not yet ready to say we will only have an OpenFlow only switch. I think that's the only difference from what Greg said earlier.
I would say that it is probably not realistic. I mean, I believe that there will be other services and other features needed on any box, even box. I think pure OpenFlow based is still, I mean, even if you look at some of the pure, like PKI, for example, there's still some things that you need to do outside of the OpenFlow protocol, period, right? Because that protocol just says, receive a packet in, send it to a controller, but there's other stuff you need to do. And I think the ASICs are very smart, actually.
But
These
I would
ASICs
say that Pika 8 will have some use cases. I think
Yeah,
you had talked about use cases. There are use cases for Dell. There are use cases for Netgear.
We're always gonna
There
have-
will be use cases for
that's the
Pika 8.
place,
There's no issue.
But
right?
I think you're absolutely right, because that room for differentiation is on the other plane. It's on the management plane. It's how you operate.
The
What
ASICs
your
are actually much
analytics
more
are.
capable, right? If you look at the ASIC, they have a lot of features inbuilt in it. So, I think at least the ones that are shipping, that are maybe it's not customized for OpenFlow only, maybe. But I think if you look at maybe the chip vendors, I'm not sure they'll ever do that, like only one purpose stuff. So there's definitely an opportunity to leverage the other features to address a broader market. So, Greg, I think you wanted to start small, which is perfectly fine. I think, but I just came from customer meeting, like I want to, don't give me a data center solution, don't give me a campus solution, don't give me a brand solution. I want to have a solution that actually is
And bring all the unicorns and let them parade around the room at the same time.
It is not my statement, but there's an expectation, at least from the being have tons of customers. They're different
I mean, I know that customers are stupid, right? And they can certainly do stupid things.
You are
Wow.
I mean,
He just dropped your building rate. Quote of the day.
And I mean, I 10 years
Greg
ago,
Farr.
I would have sat down and
Customers are
said,
stupid.
I expect the switch to be able to take packets, paint them gold, and send them on.
But
I mean, that's what you're sort of saying,
Wow.
is people actually really want to have a
Never
hundred.
seen this
But this is purely a byproduct of all the hype around all this stuff, right? And conversations of this as passionate they are actually help get some realistic expectations.
Yeah.
Whether at least now, folks, whether you agree with the viewpoints or not, at least you start to understand what the viewpoints and what the perspectives are. I think to some degree, customers will not be informed. Let me put it a slightly different way. Will not be informed until they get the opportunity to download code, roll up their sleeves, play with it, really understand, okay, this is what it does, this is really what it doesn't do. And just as importantly, do I really want to do this? If I have, a IT staff of 50 FTEs, do I really want to peel off 5 and go write packet classifiers? And for some, absolutely, yeah, it's the way I want to go because I see the payoff. Others are going to say, no way in hell, I'm going to make it someone else's problem. Cisco can deal with it. I'll go buy an application that'll run on a controller that'll do it, and then when it breaks at 2 o'clock in the morning, it's...
But to pop it even back, do you have someone who maybe wants to implement a Nextscaler, say Content Switch, who Cisco's partnered with, and instead of putting loopbacks on all their servers to do direct server return, do you want to be able to utilize a software feature in already a trusted content switching platform to be able to implement in effect direct service return without having to put in some hacks on your servers? And I think the answer to that is yes. Now, whether that's OpenFlow or 1PK, I don't care as long as I can buy the feature.
I think that this whole software-defined networking conversation, at least in my mind, has brought in two capabilities, in the limelight. One is that we need to have a way to address, at a flow level, at that granularity. You may not address all the flows. OpenFlow says I will address all the flows. In other cases, you may not address all the flows, but you do want that granularity. And how you do that, whether you use OpenFlow or 1PK or any other vendor's API, doesn't matter. But you need flow level awareness, visibility, control, even if it's on an exception basis. I think that's important. I think that is a huge kind of a step up from where we were. And the second thing is that, we have an external entity that is able to interact with the network, right? Whether it's the sole controller or whether it's a hybrid controller, external plus internal, but at least I have something external so that if I need to do route health injection, or if I need to do a special way to forward it, I have that capability. I don't have to go rip and replace, I don't have to wait for another ASIC, all of that I don't have to do. And I think that's a net benefit. I think we often get wrapped around into whether or not this widget is the best way to do that. It may be, may not be, doesn't matter. There are many widgets and different customers, whether they're stupid or informed or pragmatic, they will make their decision. I think these are the two net new things that the whole SDN conversation has brought to light. Does that make sense?
No.
No.
Well, I think that's a good way to end it.
Yeah. I mean, I'll just respond very quickly to that. If you say to customers, it's like sometimes talking to customers, like I've been a reseller, I've been an IT manager, I've been a consultant, I've been a friend, lots of things, right? And I can remember a time where I was like a 10-year-old kid, and if you came to me and said, do you want this chocolate or do you want this candy bar? The answer is, I want both, right? I want all of them. In fact, give me the whole box, right, that you've got stuck behind the back there. So I do wonder sometimes when vendors go and talk to customers and they say, what is it that you want? They want the whole box of candies, right? But they don't actually understand what they're asking for or why they're asking for them, because they actually don't know enough to understand the cost or the impact of saying, I want the whole box of candies. So if you want a router that does all of those things, you end up with a Catalyst 6500 and the architecture is so brittle that it can't do all the things. You get service modules, you get NAMs, you get supervisor engines, and the system becomes brittle and susceptible to that. So I think we need to do more to educate customers and to give them wisdom. We've spent the last decade taking wisdom away from networking engineers and teaching them that, it's all about packets. It's never been about packets, it's been about flows, always. But we always routed packets, we never forwarded flows. Right? There's a large paradigm shift that needs to go on, but we need to stop thinking about routing, we need to stop thinking about switching.
So I completely agree with you. I mean, I think an informed customer serves everybody, including the customer. This is why we do stuff like this, right?
Yeah.
It's not,
Sure.
I mean, it's kind of messy, but I think at the end, people shot me not.
I certainly have more faith in customers and their ability to make informed decisions than others, right? I mean, they make informed decisions. They don't have an option to buy a candy box at no cost, because 10-year-old kid is not paying for that candy box. He wants the candy box all lock, stock, and barrel. Now, when you say that, buddy, you only have $1, this candy box costs $20. Now you make your choices. Now he's going to start to make an informed choice, with the visibility and the experience that he has or she has. And that's when rubber meets the road, right? That's what customers do all day long. They make informed choices based on the budget they have, based on the operational complexity they need to worry about, based on the restructuring in their organization that takes place, and plus they need to make sure that the network continues to work.
No, that's not my experience in the real world. I don't know what customers you're talking to, but my experience is vastly different. Like, I'm told that I have to buy Cisco, I don't get a choice. So now the question is, what do I have to put up with? I can only choose from a given menu that you produce, and that's all I can get, because there's so little awareness amongst the organisation. And in fact, nobody really wants the network to add value. They really just want it to be, the server guys want to do everything in service. The storage guys want to do all the storage stuff in storage. They don't want to use fibre channel in the network. They don't want to do fibre channel over Ethernet, because that's not what, and the application guys don't care about application load balancers, because they just use HA proxy or Nginx. Right?
And that's fine. All I'm saying is customers have choices. Whether their CIO says, go buy from Cisco, or say, hey, go and buy best of breed components at the lowest price, right? And they have a choice to go to Netgear, or to Dell, or to HP, or to Juniper, or to Arista, or to Cisco. And they will make the choices. They will make the same choices with OpenFlow, non-OpenFlow, right? Or hybrid, OpenFlow Plus. That's a spectrum of customers we deal with every day.
I think, Greg, I think there are definitely a different set of customers who definitely have different choices and requirements. I think, and obviously there's lots of CCIEs, lots of people buying networking. Networking is not a new industry, right? It's not like somebody came up and say OpenFlow solves the world hunger and then so I'm going to buy it, right? This is the industry for 25 years and people have created different needs and wants over time. I don't think your sort of view of, give me basics and that works. Obviously, otherwise we would have never evolved from,
but the basics of where we're at with the next generation of networking, right? I keep coming back to where in the late 90s we had SNMP and we had CMET, right? And CMET was this all-encompassing, all-embracing, amazing standard with X500 integration, and it was going to be fantastic. And it looks exactly like 1PK. And then there was SNMP, and it was simple, it was cut down, it was easy to use, we could write Perl scripts against it, and it would work. And what are we using 20 years later? And we had the same thing with OSPF and OSIS and BGP, right? It took 20 years for the complex protocols to develop. I think we need to strip networking back to basics, innovate around that, and then find the complexities that we need to innovate up. Instead of trying to come from the top down, start from the bottom up, is where I'm sort of coming to. And you know, without those sorts of building blocks, we don't even know what we want. Because I think the new paradigm of flow networking as opposed to packet networking changes the fundamentals.
Sure, but you got both, right? I mean, you can just use one OpenFlow and never go near a 1PK API. And that's what you want to do.
Yeah, you have
Yeah.
choices.
I mean, I think that's our own.
I think the argument is, don't provide choices. Go to the,
We'll
go to
have
the
a whole
simplest,
different
go to the
conversation next time these guys are here.
go to the simplest construct.
I'm sure I have different
Is that
opinions.
Cisco's
You
official
get
position?
You get vanilla, and you'll like it.
Don't provide choice.
I gotta put my badge and leave.
As long as you choose Cisco, there is plenty of choice.
So I wanna change the
most
conversation.
amazing, rousing discussion, but we do have to wrap up.
I wanted to
Thank you.
have, one discussion, additional discussion. Hypervisors.
Well, that'll be a short discussion.
When can we have interoperability across hypervisors?
Well, wait, what interoperability? What level?
I
of
want to
interoperability?
move a virtual machine from one hypervisor to another.
Just go back
I want to
online.
use the APIs, same way, turn on a machine, turn on a off machine, across hypervisors.
I think
Same
you
way.
should go ask VMware that, because VMware, according to what they said at VMworld, has a plan for that this coming year.
Well, no, that's partner exchange.
No, why can't we have a standard body
I was gonna
that
say-
standardizes
I was gonna say
hypervisors?
jokingly
I
make
mean,
a standard
why can't we
body.
do that?
Well, one, the hypervisor is not differentiated more. Two, that multi-hypervisor support of libvirt and other common libraries to configure and manage them is a challenge. But if you look at, there's Citrix Zen, right? There's Microsoft Hyper-V, which is based off the reference implementation of Zen, which means they copied it, right? So you got Zen and Zen. You have KVM, which is widely used and used in most of the hold on. And then you have VMware ESXi, which is an amazing hypervisor, although not as differentiated as it used to be. But when I've talked to the product managers at VMware of when are you going to support open libraries like libvirt for management of that platform? Never. The reality is in the enterprise virtualization space, VMware is dominant. They make a damn good product, and it is against their best interest to interoperate. And then in the open cloud space, KVM's dominant, right?
So-
I get,
So I assume I think you're baiting a little bit, because what you're saying is obviously they're right, so we get that from abstractions, right? But you're at the wrong layer, right? You're talking about, at the best, at most, you're talking about a controller. I think there can be lots of different controllers, but there needs to be instruction sets for hypervisors to talk to bare metal, right?
my point is different. My point is, in the network, we have always tried for interoperability and multi-vendorness. Always. IETF, whether there are 6,000
We're
protocols
talking
or
about
not.
hardware differentiation. when
In hypervisors,
are software.
it's a completely proprietary stack. And yet, we are okay to say, hey, one vendor has 80% market share, and that's great, that's okay. And it's okay to have a proprietary stack,
Can I
but not in the network.
Can I install a hypervisor on anybody's x86 hardware right now? Pick any of those hypervisors? Can I?
No, I'm saying hypervisor as an
So,
entity.
so today there's
Then
four
when I
or
put,
five.
when I put a VM on a hypervisor,
hardware.
I cannot demotion that VM from one hypervisor to another. Why not?
Because it's not necessary in the new applications that are being
That's right.
written.
Not needed. So
It's
Nexus
absolutely
1000
not
can
necessary.
give me a common network stack between Hyper-V, KVM, and VMware, but I really don't care. Because I can get a controller that can coordinate the networking between all of them. So I can have a controller up here that talks to Microsoft's virtual switch, or OpenV switch, or VDS, and it works for me.
Well,
I don't need.
Well, and so for enterprise workloads, for enterprise virtualization workloads, there's a reason to stay inside the same platform. But all these net new applications being created right now, effectively have a cloud kernel. You don't migrate workloads, you spawn new workloads. You migrate your data. So I'm going to instantiate 100 instances over here, allow them and move my workload into it. The new cloud design patterns do not need to migrate a workload itself. Copying data is probably the closest thing to it. So is there a need to develop software to handle something for legacy workloads? No. there's software written to handle these legacy workloads to interconnect clouds running the same hypervisor. You don't need to reinvent the wheel 30 times.
That's right. We don't need end-to-end networking strategies.
Well, no, but so like
No,
1000B,
I
CSR, OTB, they're all valid technologies for enterprise workloads that will continue to be necessary for very long in the future, and it's good to continue development in that. But when it comes to investments in features, investment in software development, well, apply them where they're necessary.
I really have to stop. I will stand in the middle of the room.
I was just getting warmed up.
That's why. This has been a fabulous discussion, really. We've gotten comments online from people watching saying not, these people can argue, but saying instead, wow, I'm so glad to be watching this and listening to this and hearing this discussion. So that is wonderful. Thank you guys for doing this, and thank you for giving us the time to do this.